Welcome to Kotlin Internals Interview Crashcasts, your go-to podcast for mastering Kotlin internals for senior backend engineer interviews. I'm your host, Sheila, and today we're joined by Victor, an experienced Kotlin developer. Victor, we're going to dive into a common interview question. What are the key differences between var and val in Kotlin?
Thanks for having me, Sheila. I'm excited to discuss this fundamental aspect of Kotlin.
Let's start with the basics. Victor, can you explain the primary difference between var and val in Kotlin?
Certainly, Sheila. The main difference is that var is used to declare mutable variables, while val is used for immutable variables. In simpler terms, a variable declared with var can be reassigned, but a variable declared with val cannot be reassigned after its initial assignment.
That's a great starting point. Can you provide a simple example to illustrate this difference?
Of course. Imagine we have two boxes. One box, labeled var, allows us to put something in it and then replace it with something else later. The other box, labeled val, only lets us put something in once, and we can't change it afterward. That's essentially how var and val work in Kotlin.
Thank you for that clear analogy. Now, let's dig a little deeper. How does Kotlin's type inference work with var and val?
Great question. Kotlin uses type inference for both var and val. This means the compiler can often determine the type of the variable based on the value assigned to it. For instance, if we assign a whole number to a variable, Kotlin will infer it as an integer. If we assign text, it will be inferred as a string. However, you can also explicitly declare the type if needed.
Interesting. Let's move on to performance considerations. Are there any performance differences between var and val?
From a runtime performance perspective, there's generally no significant difference between var and val. The Kotlin compiler and the underlying JVM optimize the code similarly for both. However, using val can lead to more predictable and potentially more optimizable code. The compiler knows that a val will not change, which can enable certain optimizations, especially in more complex scenarios. It's also worth mentioning that using val can lead to better code readability and maintainability, as it clearly communicates that the value won't change throughout its lifecycle.
That's a great point about code readability. Now, let's consider different scopes. How do var and val behave differently at the class level compared to local variables?
At the class level, var properties are implemented with both a getter and a setter, allowing them to be read and modified. Val properties, on the other hand, only have a getter. For local variables, the behavior is similar to what we discussed earlier. The main difference is that local val variables must be initialized at declaration, while class-level val properties can be initialized in the constructor. It's also worth noting that even though a val property is immutable, if it's an object, its internal state can still be modified unless the object itself is immutable.
That's an important distinction. Speaking of object mutability, can you elaborate on the thread safety implications of using var versus val?
Certainly, Sheila. Thread safety is a crucial consideration in concurrent programming. Using val can provide some thread safety benefits, but it's not a guarantee of complete thread safety. When you use val for a primitive type or an immutable object, you ensure that the reference cannot be changed by multiple threads, which can prevent certain types of race conditions. However, if a val refers to a mutable object, the object's internal state can still be modified by multiple threads, potentially leading to thread safety issues. On the other hand, var properties are generally not thread safe unless additional synchronization mechanisms are used. Multiple threads could potentially read and write to a var simultaneously, leading to race conditions.
That's a great explanation, Victor. Now, let's consider some edge cases. Can you think of any situations where the behavior of var or val might be counterintuitive?
Certainly, Sheila. One interesting edge case involves late initialized properties. In Kotlin, you can use the latinity modifier with var, but not with val, to indicate that a property will be initialized later. This allows you to defer initialization, but it comes with the risk of throwing an exception if you try to access the property before it's initialized. Another edge case involves delegated properties. Both var and val can be delegated, which can lead to some interesting behaviors. For instance, you can have a val property that appears to change. This can be confusing if you're not aware of how property delegation works in Kotlin.
Those are fascinating edge cases, Victor. As we wrap up, what are some best practices and common pitfalls to avoid when deciding between var and val?
Great question, Sheila. Here are some key points to remember. First, prefer val over var whenever possible. This promotes immutability, which leads to more predictable and often more thread-safe code. Second, use var only when you genuinely need to reassign the variable. If you find yourself using var frequently, it might be a sign to reconsider your design. Third, be cautious with mutable objects assigned to val. Remember that the reference is immutable, but the object state can still change. Fourth, when using var at the class level, consider whether you really need both a getter and a setter. You can use custom accessors to control how the property is read or modified. Fifth, be aware of the scope of your variables. Class-level properties have different lifecycle considerations compared to local variables. Sixth, in concurrent scenarios, don't rely solely on val for thread safety. Consider using thread-safe data structures or other synchronization mechanisms when necessary. Lastly, when working with frameworks or libraries, pay attention to their conventions regarding var and val. Some frameworks may expect certain properties to be mutable. A common pitfall is overusing var out of habit, especially for developers coming from languages that don't have a similar distinction. Another pitfall is assuming that using val always guarantees immutability, which isn't true for mutable objects.
Thank you, Victor, for those invaluable insights. To our listeners, remember that understanding the nuances between var and val is crucial for writing idiomatic and efficient Kotlin code. In your interviews, don't just focus on the basic differences. Be prepared to discuss performance implications, thread safety considerations, and potential edge cases. Practice explaining these concepts clearly and concisely, and always think about real-world applications. Remember, interviewers are often looking for your thought process as much as your knowledge. That's all for today's episode of Kotlin Internals Interview Crashcasts. Thanks for listening, and good luck with your interviews.